Hmm. Hello and welcome to this tutorial video. My name is Leon Hady and it's really nice to have you back with us on Streaming School. I hope you're all safe and well and looking after each other and not making inappropriate comments on various bits of social media. Now, we're really lucky today to have Bucky Youssef back with us, an expert science teacher, to take us back through a range of items to do with chemistry. I hope you enjoy. And Nish is with us again. Hey, Nish.
Hey.
Obviously, I'm introducing Nish as if she hasn't been the one here all morning, and that's Mr. Latecomer Extraordinaire just joining in at this point in time. So, without further ado, I switch over to Bucky, and I wish you all a great morning.
Thanks, Leon. Hi, everyone. So, welcome to, I think it's lesson 8 of chemistry. It's been a while, actually, for a number of reasons, but we will recap by looking at covalent bonding. So those of you that joined me during my last session will recognize these two molecules are also compounds, and you'll recognize that the electrons in the outer shell are being shared between two different atoms to give you a complete and stable set of 8 electrons in the outer shell. But we're going to shake things up a little bit by reviewing our previous knowledge with odd one up. For those of you who have joined me before will recognize that I normally do the quick fire 5. I thought, let's just try something a little bit different. And you'll notice that there is a blue bar at the bottom of the screen, and that just gives you an indication of how much time you've got to answer the question. You'll have 3 possible answers, and you've got to think about which is the odd one out and give a reason as to why it is. So are you ready? Okay, so let's have a go at the first question. So, which is the odd one out of these 3 substances? You've got oxygen, sodium, and chlorine. You can notice that the blue bar is moving really quickly across the bottom. Which answer did you select? That's quite straightforward. You've got visual clues there as well, and you can see that it's sodium. Sodium is the only non-metal element. Oxygen and chlorine are, sorry, so let me say again. Sodium is a non-metal element. Oxygen and chlorine are non-metal elements. Okay, so that's quite an easy one to start us off with. What about this one? Which is the odd one out? So you've got an image that shows you the subatomic particles within an atom, protons, neutrons, and electrons. Which one is the odd one out? And more importantly, why? Okay, so you've got the blue bar moving again. Have you got your answer? Have you also got your reason? And this one's slightly trickier. Some of you might find it a little bit more difficult. The answer is actually neutron. Now, you might be thinking, well, why the neutron? It is the only subatomic particle in the atom that does not have a charge. Electrons are negatively charged, as you can see by the negative sign here, and the protons have got a positively charged. Neutrons have no charge, and that is the reason why it is the odd one out. What about with these 3 substances here? CO2, NaH2. Now, again, you've got the visuals there to give you a little bit of a hint. What do you notice that is different in one of these? What could be the same in the other 2? What did you think? CO2, why? It is an example of a compound, and you can notice this by the different colored atoms or particles that are joined together. Sodium, all the same color. Hydrogen, even though it's a gas, they're all the same color. Did you get it right? What about this one? Now, this is a little bit trickier. Which of these 3 processes is the odd one out? Melting, condensing, evaporation. And you've got the states of matter graph here, just to give you a little bit of a clue as to what may be happening and which could be the answer. What did you think? Condensing. Now, the reason is that in order for you to melt, it actually takes in heat energy. Evaporation takes in heat energy for the substance to go from a liquid to a gas. Condensing actually is a process where heat energy is being released or it's cooling down. So that's why it's the odd one out. What about this last one here? Which of these 3 substances is the odd one out? You've got ammonia, carbon dioxide, and diamond. And again, 3 visuals to give you a hint. Which one is the odd one out? What did you come up with? And the answer is diamond. And the reason is because of the fact that this is an example of a giant covalent compound. These are all, sorry, my brain went. These are all examples of covalent compounds where they share electrons, But diamond is slightly different, and that links to today's theme at where we're looking at giant covalent compounds. And today, we're going to spend a little bit of time describing and explaining the properties of giant covalent compounds. Now, those of you familiar with lessons, you'll know you've got to do now. And here, it just asks you, with these 4 images, what do they all have in common? Diamond, graphite, coal, and soot. And the challenge, if you find that really easy, how are giant covalent compounds different to simple covalent compounds? So going back to the last of the odd one out questions, how could diamond be different to things like carbon dioxide and ammonia? You've got a list of keywords which you're going to be using and explaining in this session. So what did you think about the do now answer? What do they all have in common? Well, believe it or not, they are all different forms of carbon. And I've just given you a diagram of a carbon atom there. And here's a question for you. Which word describe different forms of the same element? Okay, in this example, we've got different forms of carbon. What word will be used to describe that? Have you ever come across this word? It is an allotrope. Now, I put that there because you may come across exam questions where they use this word allotrope, and all they're talking about is the different forms of the same type of element, and carbon is one of those. Now, if we were to magnify a piece of diamond, you would notice there's lots of carbon atoms here and all these different types of bonds. And if you joined me in my previous lesson, you would know that these bonds represent covalent bonds. If we compare it to these 2 simple compounds here, ammonia and hydrogen chloride, you'll notice what makes them all similar is the fact that they've all got intramolecular bonds, okay? And those bonds are quite difficult to break. And if you can imagine, there are lots of intramolecular bonds within a carbon atom, and it may give you an idea about what type of properties it may actually have. Now, there's a lot of information on this page, and what I'd like you to do is that you can go through it again in your own time, just to recap it. But I'm going to just highlight a few key things. Now, carbon atoms can be arranged in lots of different ways in structures that we know as giant covalent structures. And here are some examples. For example, you've got diamond structure, you've got graphite, you've also got a fullerene structure, also nicknamed as buckyballs, you know, linked to my name in a way. But let's look a little bit at the properties. So in diamond, every atom, carbon atoms are connected to 4 other carbon atoms. And this means that each carbon atom shares its 4 electrons in its outer shell. So they form covalent bonds, okay? And this is what we call a giant covalent structure. Now, the properties, basically, diamond is the hardest substance, natural substance. And it's also got a high melting point, boiling point, does not dissolve in water, and it does not conduct electricity, okay? And the fact it doesn't conduct electricity means it's got a very rigid structure. So this is a very, very rigid structure. It's hard to actually break it. And there are no electrons that are traveling around to carry electricity. If you compare that to a different form of carbon, so in a pencil, you've got graphite. This is what the graphite layers actually look like, okay? So again, each carbon atom connects to 3 other carbon atoms, which means that there is 1 electron that's not bonded and it's delocalized. It can move between these graphite sheets. Now, these dotted lines here basically means that they have got weak bonds between the sheets, okay? And because of those weak bonds, it means that graphite is slippery. It can slide. However, just like diamond, it still has a high melting point and boiling point. And just like diamond, it does not dissolve in water. But it's different by the fact it conducts electricity. And this is because of the fact that you've got 1 free electron, a delocalized electron, which can actually move between the graphite sheets. So that was a very, very quick recap. But as I say, if you want to spend more time going through that, please watch the video again. Now, what we're going to do is have a progress check. I have introduced you to some key concepts and properties, physical properties of both diamond and graphite. And you've got some sentences here which talk about its structure, the graphite and diamond. And I want you to think which particular structure is linked to each of these properties below, okay? Now, if you're doing this at home, please pause for about 5 minutes to give yourself time to recap what we've looked at and actually apply your learning. Those of you with me right now will just continue and look at the answers. So the first one, Strong covalent bonds basically mean high melting and boiling point because you need a lot of heat energy to break those intramolecular bonds. Okay, so uniform 3D structure, it's hard and strong. You may not actually get that so easily, but some of the other properties, they will be easy to work out, and you could come back to the one that's not actually filled in and look at it that way. We said that there are no free electrons, so it does not conduct electricity. And if it's compact, impenetrable, doesn't actually dissolve in water, which is the same as insoluble in water. Again, with graphite, strong covalent bonds, high melting and boiling point, as we said before. So you've got the lattices or layers that can actually slide past each other, which means that it's slippery, they can slide past each other, or soft in comparison to diamond. And what makes it different to diamond is it's got one electron, or sorry, some electrons that can, sorry, one electron that can actually move between the sheets and lattices and conduct electricity. Now, with this, we can actually, believe it or not, apply this to an exam question. We've got two parts to this. To demonstrate exam question 1. So you've got two images, two forms of carbon, allotropes, graphite and diamond that we looked at before, and we'll read this question. Graphite and diamond have different forms of the element carbon. Graphite and diamond have different properties. The structures of graphite and diamond are shown below. And whenever I give you an image in an exam question, please use it, because sometimes they give you a little bit of a hint or a clue as to the type of things you need to write down in your answers. So for 4 marks, graphite is softer than diamond, explain why. So if you've actually engaged with my previous lessons, you will always know that I remind you to think of the keywords, think of the keyword points that will get you a mark, and make sure that your answers are clearly explained. But let's unpick this exam question a little bit more. So it said graphite is softer than diamond, so you can actually look at the image that they gave you in the exam question. I've included it just for your reference. Explain why. If you break it down, write a point, and give a reason for your explanation. So what would be the most important keywords to use? Graphite layers slide. You can see that in the image. There are weak forces between the layers. I did mention that before. They're represented by the dots, but they're not in this image. However, it still is the case. And diamond carbon atoms bond to 4 others. Okay? And the fact that diamond carbon atoms cannot slide. So you've got 4 key points and 4 key words included. So this is the answer. Carbon atom layers in graphite can slide for 1 mark because of the weak forces between the layers for another mark. Diamond carbon atoms are strongly bonded to 4 other carbon atoms for your 3rd mark, so the atoms cannot move for the last mark. If you've got something that is similar to this, that means you've answered that question completely. It's not easy, I know. So again, what did you do well? Were there any particular keywords that you used? And what do you need to improve? And usually at this point, it's making sure that you can clearly write your explanations to get the marks that are needed. So let's look at a second question related to this topic. Graphite conducts electricity, but diamond does not. Explain why for 3 marks. So again, give you keywords, the key points per mark, and make sure they are clearly explained. So if we break that down, we've got the image again, just as a visual reminder to help us remember why graphite conducts electricity, but diamond does not. Explain why, write a point, and give a reason behind it. But the type of keywords that you need to include are the fact that graphite has got delocalized electrons, but diamond does not. And in order for it to conduct electricity, the currents or electricity has to go through the structure. So there's some of the keywords that you need to include. What type of answer would you write that links those points together? Okay, graphite is delocalized electrons, which can move for 1 mark. Electrical current goes through the structure of graphite for another mark. And diamond does not have any delocalized electrons for 3 marks. So how did you do with that one? Okay, so quick review. What are the 3 key things, key ideas that you can remember from today's topic? What are the 2 new things you've actually learned? And what is 1 thing that you will research further on this particular topic? So as part of your further thinking, I want you to think about which other natural minerals are found on the earth. And diamond is an example of many types of other minerals you can actually see. And I want you to think about what type of structure do you think they actually have. So if you can actually Google this, It's Mike, I can't even say his name, Simatano, mispronounced his name most directly. But if you actually Google or go to YouTube, A Brief Introduction to Minerals, it's about maybe 7 minutes, but it's a very interesting overview about the different types of minerals that are found on Earth and the type of structures they actually have, which links to today's learning. Thank you very much for joining me. Take care, and I look forward to seeing you soon.
Thank you so much for that, Bucky. Really, really appreciate it.
You're welcome, Leon.
I'm going to try to gather my thoughts before commencing any opening of the mouth and saying anything, because I'm still finding something from earlier quite humorous.
Okay.
Compose myself, and I will be right back, and we will be back with you shortly for a wonderful maths lesson. Nish, there's stuff that you say at the end of these, isn't there?
Yep, and I was going to share my screen and say it.
I remember how this works.
There were 2 questions from this. I hope I got them right, Bucky.
I can see them there.
Yeah. So the first one is how are diamonds formed, and the second question is research 2 other giant covalent compounds and summarize their physical properties. So hopefully that session would have helped. If you've missed out on any sessions, they're on Facebook and on YouTube with questions and any resources. And up next we have mindfulness. Or maths. Do we have maths first, then mindfulness?
I will talk to you about that in the short interlude that we'll have, and I really look forward to seeing you in
mindfulness.
another 5 minutes.
Okay, thank you.
Thank you.